our question. So
Yes, yes.
we have just calculated this question, okay, and just one step is left. Means here this is phi, and we have to put the value of electric field. And due to a charge at the center of the sphere, and
Yes, sir.
if we want to calculate this electric field, which is at a point which is at a distance r, then we will write k means 1 upon 4 pi epsilon naught into charge. Charge is plus q divided by r square, and this is multiplied by 4 pi r square. And now you can cancel the terms, which are 4 pi is cancelled with 4 pi, and this r square will cancel with r square. So the total flux through total electric flux through this spherical surface will be this plus q uh, divided by epsilon naught. So plus q divided by epsilon naught. This is the that I have left. I have not calculated the whole thing in the last class. So now I have calculated the whole thing. So you can say that if uh, closed surface here is the sphere enclosing a charge plus q, then the total electric flux is charge enclosed divided by epsilon naught, and this is our Gauss law. This is our Gauss law.
Also.
So Gauss law says that if you are having a closed surface, then if you want to calculate the total electric flux passing from that closed surface, then you will take the total amount of charge inside that closed surface and divide it by the epsilon naught. That will be your total electric flux. That will
Yes,
be
sir.
your total electric flux. So these are the questions of the assignment I have given yesterday. So we will discuss it. First question is very easy. So they are saying define the electric flux, and see number of times this question has appeared in the exam. So electric flux, you can say the number of electric field line crossing crossing an area perpendicularly. Simply you can write. If you want, then you can write a formula also. So I am taking this question. This question is I will say a good question. So they are saying given the uniform electric field is given, okay, we have to
Yes.
find the flux through this field through the square of 5 centimeter on a side whose plane is yz plane. Whose plane is yz plane means we have the square on yz plane. Suppose this is y axis, this is z axis, and we have the square.
Yes, sir.
And the area of this square is and the side of the square is given as 5 centimeter. So this side is 5 centimeter. So area of a square is equal to side square, means 5 centimeter square. If you will convert it into meter, then it will become 5 by 100 multiplied by 5 by 100. So the area of this square will be 25 divided by 100, or and into this will become 10 to the power 4. So you
Yes,
can
sir.
write this is 25 into 10 to the power minus 4 meter square is the area of this square that you have. And the electric field here is given, and the direction of the electric field is along the x-axis. Okay, this is I cap, and I have
Yes, sir.
told you I cap represents the x-axis, so I am taking
X-axis.
in this direction as x-axis.
Yes,
Okay,
sir.
and also this is the plane of this area, and we also have to find the normal vector, means we have to find the area vector. So for the area vector, what we will do, we should have the magnitude of the area, means a, and
Yes,
the
sir.
unit vector, in the perpendicular direction of the area, means a vector, means unit vector of area we have to find. So what is the meaning of unit vector? I have told you, if your area is in yz plane, then unit
Yes,
vector
sir.
will be along x-axis. And what is the unit vector along x-axis? It is I cap.
I cap. Yes.
So for the area vector, you can just write the magnitude first. means A, and I cap you can write this is your area vector. And electric field is given simply. So you will apply this formula. Phi is equal to E dot A. So the electric field you can see from here 4 into 10 to the power 3 I cap.
Yes, sir.
10 to the power 3 I cap, and dot of 25 into 10 to the power minus 4 J cap. And if you will not J cap, yeah, it is I cap again. Sorry,
Yes, sir.
it is I cap again. So I have told you if you want to just multiply, so what you will do? Here is I cap, here is I cap. Okay. So when you will multiply means dot, you will take that dot of I cap with I cap. This is equal to 1, and these are the numerical values. So you can just multiply it like the multiplication. So this will become 25 into 4. So 25 into 4 is 100, and this is 10 to the power 3. This is 10 to the power minus 4. This is 10 to the power minus 1 you have. So finally you have this 10 voltmeter is your answer of flux. So this is the question asked in 2014, and again
Okay,
the
sir.
CBSE has asked the same question like this, similar question you can like this. They have given the electric field. This is also in 2014. This is this question. So here they are saying given the uniform electric field this, and find the flux of this field through the square of side 20 centimeter whose plane is parallel to YZ plane. Whose plane is parallel to YZ plane means this
Why that?
area is in YZ plane. Okay. And what will be the
Yes, sir.
flux through the same square if the plane makes an angle of 30 degrees with the axis? So first thing, for this type of question, you should know the plane of area and the
Okay.
normal vector of that area. So this is the area you have, and this area is in YZ plane. So
Yes,
there
sir.
will be the axis, x-axis, and which is perpendicular to this YZ plane. Okay.
Okay,
So
sir.
unit vector of the area will be I cap. And if you want to calculate this magnitude of area, so this is the square of side 20 centimeter. Square of side 20 centimeters. So what you will do? Area of square is side square, and you will convert this 20 centimeter into meter. So this will become this like this. So this will become 20 into 10 to the power minus 4 meter square. So area vector will be area into A cap. So what is area? Area is 20 into 10 to the power minus 4 into
Okay.
I cap. Okay. This is your area vector, and you can take the unit also, meter square. And electric field is given as this is the electric field. So you can simply apply this formula. Phi is equal to E dot A. So E is given as 2 into 10 to the power 3 I cap. 2 into 10 to the power 3 or minus 3 or 3 I cap.
Yes.
2 into 10 to the power 3 I cap, and you will take the dot product. Here you will write area vector 20 into 10 to the power minus 4 I cap. Again, I cap and I cap I have told you here. I
One.
cap
Yes,
is
sir.
1, and just you will multiply this 2 into 20. This will become
40.
40 into 10 to the power minus 1,
Yes, sir.
and this will become 40 by 10, and you will get your answer 4 volt into meter. And one part extra given in this question, they are saying that this thing is completed. First
Yes,
part
sir.
of this question is completed. They are saying find the flux of this field through the square of side 20 centimeter whose plane is parallel to the YZ plane.
Yes, sir.
Okay, now they are saying what would be the flux through the same square? What will be the flux through the same square if the plane makes an angle of 30 degree with the x-axis? Now what we have done? This plane of square is making an angle of now same square I am taking,
Yes, sir.
and this square uh, is now making an suppose this is your x-axis or I cap. Okay, I cap direction or x-axis, this is your, and the plane of the area, this plane of area, I have to change it a little bit according to the question. Just suppose this is your x-axis in this direction. This is your x-axis means I cap. And the plane of the area is this, means this is the plane of the area. And this, they are saying this plane of area making the angle of 30 degree. 30 degree, na?
Yes, sir. 30
Okay, 30 degree with the x-axis. So this is the x-axis and this is the plane of area.
Yes,
And
sir.
this plane of area is making an angle of 30 degree
Yes,
with
sir.
the x-axis. Okay. And now they are asking that what will be the flux for the same square if the plane makes an area of 30 degree with the x-axis. Now this area is not in x z y z plane. Okay, now plane has changed, and accordingly the angle with the x-axis has been changed. Here this area makes the angle of 90 degree with x-axis. Now this area is making an angle of 30 degree. Now
Yes, sir.
we will, there is a requirement of this a cap, and this a cap will be perpendicular to this area, means this whole angle will be 90 degree. This whole angle means this whole angle will be 90 degree.
Okay, sir.
And you have to just calculate the angle between the electric field and this unit area vector. So this angle will be 60 degree. Okay,
90 minus 30, that's sir.
90 minus 30, and electric field is also along in this direction.
Yes, sir.
So the theta, what is the theta? Theta is the angle between the area vector and the
Yes, sir.
electric field is in this direction, and again also you can say this area vector is also in this direction.
Yes, sir.
So theta is the angle between the area vector and the electric field. Now we have got this
60.
60 degree. Now what is the, now we can apply this formula, na? Phi is equal to EA cos theta.
Yes, sir.
EA cos theta we can apply, or either you can also self solve it with the help of this vector, but I think this will be more easy for you. So electric field this time is given as 2 into 10 to the power 3 I cap. So 2 into 10 to the power 3 I cap is the electric field. If you want to find the magnitude of electric field, just you will write only this value.
Okay, sir.
And for the area, if you want to just write the magnitude, you will write only the value of this A, that is 20 into 10 to the power minus 4. And theta we have, so you can apply phi is equal to EA cos theta. Electric field magnitude is 2 into 10 to the power 3. Area is 20 into 10 to the power minus 4. And cos 60 you will take. And this will become 40, means 4. When you will multiply this 20 with 2, 40, and when you will multiply this 10 to the power 3 with 10 to the power minus 4, it will become 4. Cos 60 is 1 by 2. So you will get your answer 2 volt. So this was the second part, I will say, and this part is little bit confusing for you. So you have to just remember that the area vector means the angle that area vector is making with the electric field. You have, and we already know the electric field is along x-axis. So now you can take the screenshots of this.
Okay, sir. So can you zoom out?
Taken?
Yes, sir.
Done.
Yes, scroll down, sir. Yes.
So I am giving it a 1 star. Well, from here the language or the thinking process will change from.
Okay.
Now we were discussing the Gauss law. We were discussing this Gauss law. We have just done this Gauss law, and now there are the few properties of Gauss law that I will write. So Gauss law, we know that what is Gauss law. You can write again. Gauss law is a law used to calculate the electric flux. Electric flux is given by charge inside of closed surface divided by epsilon naught 0. And this epsilon naught 0 is the absolute permittivity of free space or air. And this can also be given if you will calculate A dot ds. So there are some basic properties, there are few properties of Gauss law. Number one, flux is independent of shape and size of closed surface. So for an example, you are having a sphere
Yes.
and this contains a charge plus q. Suppose you are having a bigger sphere, this also contains a charge inside plus q. Suppose you are having a cylinder, this cylinder is also containing the charge plus q. Suppose you are having a cone, this cone is also a closed surface and this containing the charge plus q. From all these surfaces, the electric flux will be plus q divided by epsilon naught.
Okay. For all of them, sir?
Yeah, from all of, because according to the Gauss law, what Gauss law says? Gauss law says that flux coming out or entering, or you can say total flux from the surface of a closed surface is charge contained inside the closed surface divided by the epsilon naught. So this is irrespective of the surface. Okay. So no
Okay.
matter which surface you have, so the flux will always remain same, but you should know what is the charge inside. Okay, second property, and flux is simply the electric field line crossing the area perpendicularly. So if you have a same charge inside, you can imagine that the number of field lines will remain same. Okay, remain same number of field lines, no irrespective of the shape. So this is the thing that. And second, now we will talk about the sign convention. Inward flux is negative and outward you will take is positive. Now how inward and outward will be decided? Suppose this is the sphere and this sphere having the minus q charge. So suppose the electric field line is entering this closed region like this. Electric field lines is entering this closed region or closed surface like this. So
Yes.
these are what is the electric flux? Electric flux is the number of field lines crossing the area perpendicularly. So here the electric flux you will take negative electric flux, because these electric field lines are entering this cross section, entering
Yes,
this
sir.
surface. So phi, and from the Gauss law you can say that you will write total charge contained inside. What is the total charge? Minus q,
Minus.
and divided by epsilon naught. So this flux is negative automatically, and we
Yes, sir.
already know that the electric field line is electric field line terminates at the negative charge. Okay, so here the electric field line is going towards this negative charge. Same is the case you will take, not same, means suppose you have a plus q charge. So this time the electric flux will be like this. And this flux you will take as positive, this flux is negative. Here phi is negative. Why phi is negative? Because the electric field line is entering the surface. Or
Yes, sir.
you can see from this formula also. And here, if you will go to the formula, means charge contained inside divided by epsilon naught. So you can say phi is positive. Why the phi is positive? Because the electric field line just leaving this cross section. Means,
Yes, sir.
okay. And there is one more point. Charge outside the closed surface will not contribute to flux. So see, what is the meaning of this statement? Suppose you are having this closed surface, and you have two charges here, plus one charge you have, and minus q2 charge is here. And suppose you have here a minus q3 charge. So if you want to find the flux through this surface, and here is another charge outside this surface, then the flux will again be total charge contained inside, means q1 minus q2 divided by epsilon. Means you will not take this charge outside the surface charge, you will not take for calculating the flux.
Yes.
Now fourth point is, if field lines are crossing the closed surface, the flux is zero. Suppose the closed surface means, suppose you are having a sphere, and this is your closed surface sphere, and suppose the electric field lines are like this. Electric field lines are like this. So these are the electric field lines. So you can say here, the number of electric field lines entering the surface is equal to the number of field lines going out of the surface.
Yes, sir.
So here, three field lines entering, perpendicularly entering. So you will write entering flux, you will take negative. You can see the entering flux is
Yes, sir.
negative. You will take phi is equal to minus 3. Phi1 suppose is -3 you have, and 3 field lines are, or you can say leaving the surface. So what is the flux? Flux is the number of field lines crossing unit area, crossing the area. Phi2 will be +3 because leaving flux we will take, and if you want to calculate the total flux, then you will write phi1 plus phi2. So what is phi1 is -3, this is +3. Overall it will become 0. So this is the reason that if the field lines are just crossing the closed surface, in that case the total flux will be 0 because entering flux is equal to the leaving flux.
Yes.
Okay, there is one more point. Suppose you are having a closed surface like this, and suppose you have a -q and +q charge, means suppose you are having a dipole. You are having a dipole. Can we calculate the electric flux with the help of Gauss law? Crossing this cross section means crossing this area.
Yes, sir.
According to Gauss law, what is the total flux? Total charge contained inside. What is the total charge? -q charge plus q charge divided by epsilon naught. This will become 0 because
Yes.
this quantity is 0. Yeah, okay. So due to the dipole, if you are having a dipole inside the sphere or inside any closed surface, then total electric flux or net electric flux will be 0. So okay, now you can note it down. You can note it down. Then we will solve some question after that. There are some simple things that you have to remember. Flux is something, if you are just imagining the flux in your mind, what you should imagine? You should imagine flux is nothing but the electric field lines entering or electric field lines leaving. Simple. So this Ziyad, are you writing today or you want to take the screenshots?
Sir, I think, yeah, right.
You are writing?
Yes. Can you scroll down,
Very,
sir?
very good. Yes.
Yeah, I wrote those parts. I need to write the third ones.
Third one.
Yes, sir.
And these properties are very important. Very important for the electric flux. These
Yes.
properties will help you, okay, in
Yes, sir.
solving many questions.
Sir, can you scroll down to the fourth ones? Yes, sir. Okay, sir.
And these are the electric field lines. Electric.
So finish, sir.
Okay. Now we will have some questions. So this is our first question. So see this question. Uh, so you can see this question. They are saying that uh, a charge is placed at the center of cube. This is a cube
Yes, sir.
and cube, and they are saying calculate flux through this cube and flux through each surface. Flux through each surface. So this cube is a closed surface now. Means
Yes,
this
sir.
have the this cube have six faces. This cube have six faces. You can count if you want. One, two,
Yes, sir.
okay, three, four, okay, five, and six. Like
Six.
this.
Yes.
Two faces are like this,
Yes, sir.
okay, and two faces are like this,
Yes, sir.
and two faces are like this, like this.
Yes, sir.
So the cube have six faces. You should remember this point. And the first part is very easy. For the first part, if you want to calculate the flux through a cube, flux through cube means phi we have to calculate for the cube. What we will do, we will apply simply the Gauss law. Gauss law is charge inside divided by epsilon naught. What is charge inside of the closed surface? But the condition is that the surface should be the closed surface. Okay. So charge inside is here plus q only,
Yes, sir.
and this is plus q divided by epsilon 0, and this is your answer. I mean, this is the flux value of the flux which is coming out of this cube. Now in the second part, you have to apply the unitary method. I will tell you what is unitary method. For the second part, they are saying flux through each phase. So, Ziyad, this phi is the flux now. Phi is the flux through all the phases. Okay,
Yes.
this flux is total flux through all phases, or you can say this is the total flux.
Okay, sir.
If means for six phases, or you can say from six phases, from six phases, if flux is qy epsilon naught. So what is the flux through one phase? If flux from all the three phases, all the six phases is this.
Yes.
Okay, and if you want to calculate the flux from one of the phase, so
From one of the face.
from one of the phase will be 1 by 6
Yes, sir.
of qy epsilon 0. Why? Because this have these six phases. Okay,
Yes.
you can imagine this like mm, mm, means suppose you have this area and you have this area. Okay, means you have one phase is this, your another phase is this, and
Yes.
someone and both phases are equal and symmetrical, and someone is saying total flux from both the phases is 6. So what is the flux through this one surface? You
1 by
will
6.
just multiply this 6 by 2.
So 6 by 2,
Okay.
sir.
Yeah. Multiply by 2. Oh, sorry, divided by 2. Sorry. Okay.
Yes, sir.
Then you will get, no, you will get your answer as 3. Suppose
3.
I am saying now you are having 6 faces. You are
Yes, sir.
having 6 faces. And from this all 6 faces, you have a flux of q by epsilon naught. And if you want to find the flux through one phase, so what you will do? That time you have 2 phases, then you have divided it by 2. Now you are having the 6 phases, you will divide it by 6.
1 by 6. Yes, sir.
1 by 6. So, okay. So this is our answer
Oh, yes.
for this question. This is a very easy question. Now moving to the next question. They are saying that a charge q is placed at one of the corner of the cube. At one of the corner of the cube, they are saying. So I am taking this cube. This time the charge is at one of the corner. So I am taking this corner and a charge q is there on one of the corner of the cube. Calculate flux through cube. They are saying calculate flux through cube and they are saying flux through each phase due to this charge.
Yes.
This type of, for solving these types of question, you have to think, you have to think, you have to make the symmetrical figure. And there was a chapter in the physical chemistry, solid state. I think now that chapter has been removed from your syllabus. So this corner of the cube, this corner of the cube can be shared by 7 more cubes. Okay, from
Okay,
the
sir.
7 more cubes. Okay, so when you will add 7 more cubes, add 7 more cube means you will add 1 cube here, here you will add 1 cube, and here in this direction means in like here you will add 1 cube, in the back side you will add 1 cube. Okay, so you will add 7 more cube, and when you will add 7 more cube you will have a bigger cube, you will have a bigger cube. Okay, so I am just making a cube big which is bigger, and now you will see what will be the condition. This is the bigger cube we have, taking it a bigger, but this time what will happen? uh, this charge will be at the center. Just wait a minute.
Okay, sir.
uh, it is difficult, it is little bit difficult to understand means what the things are going. So what you have done, you initially you have this cube, you have added 7 more cube to make a this one cube, and you have added 7 more cube like that. Your this charge q will be at the center. Okay, so
Okay.
charge q is at the center and this is a big cube, or you can say bigger cube. After adding 7 more cube to given cube, Very simple. Now, one big cube is equal to 8 small cube. Means earlier we have one cube and we have added 7 more cubes. So this one big cube contains how many cube? 8 cube now.
Yes, sir.
One big cube is equal to 8 smaller cubes. Now you have to focus on this cube only, bigger cube. This bigger cube is looking like that. This contains a charge q at the center.
Yes, sir.
Means you can write bigger cube have q charge inside, or you can say center. So flux through this bigger cube, will be charge contained inside divided by epsilon naught.
Yes, sir.
Simple.
Yes.
So you can write flux through the bigger cube is this, and this bigger cube is made up of 8 smaller cubes. So you can say flux through 8 small cubes. Flux through 8 small cubes. I am just writing in the written form. Is equal to q by epsilon naught, because one bigger cube is equal to 8 smaller cubes. Okay, and
Yes.
this is q by epsilon naught, and 8 is, and for 8 smaller cubes means for 8 cubes you have the flux q by epsilon naught, and if you want to just calculate the flux for a single cube, flux through one small cube given, what you will do, you will just divide it now by 1 by 8, and this is your answer. So this is the way to solve this kind of question, but you should know that here the side we can make one bigger cube by adding 7 more cube, then we will get this structure, and with the help of this structure we can calculate the flux through this whole cube, and this whole cube is made up of 8 cubes, and flux through 8 cube is q by epsilon naught, and if you want to calculate the flux through 1 cube, then you will divide it by 8. So this is your first answer. Okay, just make it as a 1 star, mark it on our star, and here 2 star,
Okay.
because thinking process you have to little bit increase your not increase, you have to go, so suppose you are here and you have to go little bit up, otherwise no problem. Second part, if you want to calculate, they are saying, for the second part they are saying flux through each phase, flux through each phase. Now flux through each phase means flux through one cube is this 1 by 8 into q by epsilon naught. Flux through one cube is flux through given cube is q divided by 8 epsilon naught, and in one phase, or sorry, in one cube there are 6 phases. If we want to find the flux through one phase, what we will do, because the cube have the 6 phases, so we will write 1 by 6 of this, and
Yes,
you
sir.
will get your answer q by 48 epsilon naught, and this is wrong. Why
Yes,
this
sir.
is wrong? Why this is wrong? Because the thing is that you have to imagine like that. Means just I am writing something. this na, uh, you have a charge here na, you have a charge here. This charge will contribute the flux only to the three faces only. Okay, this charge will not contribute flux to this face. Okay, this charge will
Okay.
not contribute flux through this face and this face. Means the faces which are adjacent, means this, here is a charge, this charge will not contribute. I am giving the name, suppose this is A, B, C, or this is O, A, P, and this is Q. So the faces, to the faces, the this charge will not give the flux or will not contribute the flux, will be A, B, C, O, or OBQA, OBQA, and OCPA, OCPA, PA. These phases will not have the flux due to this charge, because you can see this charge is like this. So the electric field line from the charge will be like this, and like this. Okay. And when you will calculate the flux through this surface, then the angle between the area vector and the electric field will be 90 degree, and that is that flux will become zero. So you have to remember one thing. I am writing here. Three faces will share charge. Will not contribute the flux. Okay, here are the three faces. One phase is this, that is sharing the charge, and one phase. These three phases are the phases which are sharing this charge, and this sharing charge phases will not contribute to flux, will not contribute the flux. So the net flux due to this charge will be given to the three phases only. So you can write only remaining phases, those do not share charge, will contribute to flux. Flux means remaining phases means like remaining, you can say remaining three phases. So flux through three phases we have to calculate. We have flux through three phases. Okay. If you want to calculate, then what you will do? You will just multiply this 1 by 3 with q by 8 epsilon naught, and your answer will be q by 24 epsilon naught is your correct answer.
Okay, sir.
So this question is little bit typical, I will say. I am
Yes.
giving it a 2 star, and so what is the time? I think time is also over. We have one more question, then otherwise we will not be able to start the new topic in the next class. So this question is very, very easy again. This question is easy. See this question. They are saying find the flux through this hemisphere. Find the flux through this hemisphere. And this hemisphere contains the charge Q here. Okay.
Yes, sir.
Suppose this is the hemisphere and here is somewhere charge is placed. So what you will do, you will just complete this hemisphere. You will just complete this hemisphere and you will make it a sphere. Now it is looking like that. This is the sphere. This is the sphere containing the charge q at the center. So what is the total flux? What is the total flux through hemisphere? Will be q by epsilon naught.
Yes, sir.
Okay, and hemisphere is the half of this sphere. So if
Yes,
you
sir.
want to find the flux through hemisphere, then you will write this half of q by epsilon. This is your answer, means q by 2 epsilon naught. So in these types of question, you have to just complete the geometry, means you have to make the closed figure, and accordingly you can divide the flux. Accordingly you can divide the flux. So now you can take the screenshot of the answers.
Okay, sir.
Just I'm zooming it out. And remember, all these questions that today we have solved, all are important except this first question. This question
Okay.
is very, very easy. Anyone can solve it. But the second part is, you can say, important. But other two questions are very, very.
Okay, sir.
Gauss law makes easy to calculate the flux. Okay, Gauss law makes, with the help of Gauss law, it is easy to calculate the flux. Should I scroll down? I've taken the, or you are
Yes,
writing?
sir.
Are you writing or should I?
No, I'm taking screenshots, sir.
5 to 6. We have a class till 6:30, na?
Yeah, sir.
Okay, I was thinking that we have a class at 5. Okay, so no
Sir, it's
problem. Take.
actually 1 hour, sir, actually. It's supposed to be 1 hour, sir.
Actually, today I am not feeling well, na? So that's why the things,
Oh, okay, sir.
different things are happening with me.
Yeah,
Okay, so
sir.
you can take the screenshot of this also.
Okay, sir. Sir, can you scroll down?
Yeah. Scroll down.
Yes, sir.
And remember that this question is a important question, I would say, means a good question.
Okay, sir.
Scroll down now.
Yes, sir.
So Ziyad, means, are you getting na? Means what I am just doing. I have
Yes,
just
sir.
done what I have done.
Yes, sir.
Here is the thing na, means it is, I think some students are not able to digest the thing that how this can be happen. How this can happen. Like here I have done. In this case, how sir you can do this? So actually, we are not fighting with the question. We have to solve the question. Okay. So we have to
Okay.
make the ways to solve the question. So I am telling you the way to solve the question. So what I have done, this was the hemisphere earlier, and this
Yes,
have the
sir.
charge as the center. But
Yes, sir.
this was not the closed surface. This was the open surface. So
Yes,
what
sir.
I have done, I have make it a closed surface. I have imagined that. Okay, I have taken this imaginary sphere, a hemisphere, and club it on it. So this system or this figure will looking like that. This is the sphere having the charge at the center. Okay, charge at the
Okay, sir.
center. So why I have done this? Because I know that according to the Gauss law, if we have a closed surface, always remember that you always have to make a closed surface with respect to charge. Okay, so here I have made a closed surface. Now a sphere is a closed surface, and what is the flux total that is coming out of the sphere? That is q by epsilon naught. And we have to calculate the flux through this hemisphere. This will be half of the total. Okay.
Okay, sir.
So these are the possible varieties of the question that you may get in your exam. Now see this. This here is a cylinder given. Here is a cylinder given, and axis of the cylinders are given. You can see here the axis of the cylinders means this axis is the x-axis and this axis is the y-axis is given, and this is origin. Origin means the reference point is given, and they are saying that uh, calculate flux through cylinder. Calculate flux through cylinder if electric field is like this for x is greater than 0. X is greater than 0 when you are moving from origin to this side. Okay, this is positive x-axis and this is, you can take,
Okay.
negative x-axis. This is x-axis, but this is negative x-axis. And in this direction the unit vector is I cap. Here is unit vector is minus I cap. So talking about the electric field, so I am just copying this figure. Thank you. I'm just copying this figure to make you understand what is happening. Why this eraser is not working properly? Okay, no problem. It's fine. So I am zooming it. I want that you should see what is the condition. So from this zero, from this origin to here will be some point, you can say, means when you are moving from this origin to in this direction, you will find the electric field E naught. Okay, you will find the electric field E naught. Okay,
Yes.
means in this direction the value of electric field will be E naught. You can see from here this I cap is only showing the direction of the electric field. Okay, means positive I cap means the electric field direction is from in this direction, like this. The yeah, just a minute. Like this. If you can draw, what is here in this direction, the electric field is E naught. Okay, because here is given from x is greater than 0, and this is the area. Here is x is greater than 0 and here is x less than 0, because you are moving on the left of this origin, and here the electric field will be in this direction, and having the magnitude E naught.
Yes, sir.
You can see from here now. You
Yes, sir.
cannot say this is minus E naught,
No,
because
sir.
minus I cap here, you will take the direction of minus I cap. Okay, now it's fine. Now how many areas you have? You have 3 areas. See how you have 3 areas. Are you okay with red color? Yeah.
Yes, sir. Yes, sir.
First area is this. Second area is this. Area is very important in calculating the flux. And another area is the surface or the curved surface area of the cylinder. This area A1 you have,
Yes,
another
sir.
area A2 you have, and this curved surface area I am supposing as area number 3. And direction of electric field is only along the either positive x-axis or on the negative z
Negative
x-axis.
x-axis. Yes.
Now we will use the not area, we will use the area vector. Okay, area vector, or we have to find the angle between the electric field and the area vector. So see here now, this area is like this now. So the area unit area vector will be in this direction. The direction of this area will be in this direction.
Yes, sir.
Perpendicular to the area is the direction of the area vector. Okay, so this is the direction of area vector.
Area.
Why I am
Area.
taking this direction? Because 90 degree
90 degree.
is the direction of the area. When you are taking
sir.
a vector which is 90 degree to area, that is the direction. And direction of this area vector will be like in this direction. Now, if you are taking an area here, if you are taking an area here, the direction of the area vector you will find here. Suppose this is A1. Because area vector is always normal to the surface. Here also this area vector is normal to the surface here also. But you can see the direction of electric field is along x-axis. So
Yes,
here
sir.
the direction of electric field you will take either is in this direction or either is in this direction.
Yes.
Now, suppose through this area A1 the flux is phi1. Through this area A2 the flux is phi2. Through this area A3 the flux is phi3. Now I will calculate phi1, phi2, phi3. So phi1 is EA cos theta.
Yes, sir.
And what is the electric field? Electric field is constant, and that is E naught along x-axis. So I will
Yes.
write E naught. And area vector. Now area vector, you will write direction of the area vector is this now.
Yes, sir.
Okay. So you will write this as
Yeah.
oh shit. Just a minute.
Okay, sir.
Okay, Ziyad. So E naught is the area. We are talking about this area and this electric field. We are just
Yes.
calculating the flux through this area. So what is the formula of flux? EA cos theta. What is electric field? Electric field at this area is E naught, and what is the area vector is this A.
Anyway. Yes.
If we are talking about the magnitude, then we will take it A. And what is the angle between the area vector and the electric field? 0 degree, because the direction of area vector and direction of electric field is along x-axis. Then we will take this as cos 0. So here you will have E naught into A. Okay, E naught into A. And what is E naught is E naught, and what is the area of this is the circular area. If R is the radius of this R suppose is the radius then of this circular area, then you will write pi r square is the area. So A into pi r square. Now when you will calculate phi 2, again you will apply EA cos theta.
Yes, sir.
What is EA for this area? EA is E naught
E naught, yes sir.
and
E naught
area
square.
is again area. Both the
Yeah.
areas will be same. Magnitude of both the areas will be same. That will be pi r square again. And cos 0 is 1.
Oh yeah. Yes sir.
So this will become E naught into pi r square. Here also the cos 0 is 1, so I have not written here. So phi 1
Okay.
and phi 2 you will have. Now you have to calculate phi 3. For phi 3 again you will apply EA cos theta. Electric field is in the x direction. Either the negative or the positive means electric field is E naught. Talking about the magnitude only. And what is
Okay.
the area? Area is this A1.
Yes sir.
Area is A. Means if you will take the area vector or area A1. What is the angle between the electric field and the area at this time? This is 90 degree now.
Yes sir.
So you will write here cos 90 degree and value of cos 90 degree will be 0 degree. 0.
0. Yes sir.
Cos 90 will be 0. So the phi 3 will become 0. Phi 3 will become 0.
Yes sir.
And but one thing here, I have done a mistake here because this is a not this plane area. This was the plane area. This was the plane area. This is not the plane area. So you have to use here for phi 3. You will use this expression close interval of means close integration of E dot ds, and E is constant. So you can write it as E into ds into cos theta. This E is the constant and this is E naught, and ds is this area is ds. Okay, this is not A1. This is a smaller area. This you will take ds. This area is ds. This area. This is the area on the curved surface of the cylinder. So
Yes.
you will take this as ds. And what is the angle between E naught and ds? E naught and ds is 90 degrees. So you will write here cos 90.
Yes sir.
And the cos 90 is 0. So whole thing will become 0. So you will have
Okay.
this phi 3 is equal to 0. Now if you will calculate the total flux from the cylinder, then you will add phi 1 plus phi 2 plus phi 3. What is phi 1? Phi 1 is E into E naught into 2 E naught into pi r square. Phi 2 is again E naught into pi r square. And what is phi 3 is equal to 0. So finally you will get your answer 2 E naught when you will add pi r square. So this is your total flux through the cylinder. So this is your
Okay sir.
total flux. So this is a type of question that here you have to apply the formula for the plane area also, and also you have to apply the formula for the uh, curved area. Okay, for curved area you will use this formula. I have told you the surface
Yes.
integration you will use. So now you can take the screenshot of this. I will say this question is a good question.
Okay sir. So can you scroll down?
Yeah. Now the Gauss law is completed. Uh, Gauss law is completed now.
Okay sir. So can you scroll down? Okay sir.
Okay, so, if you want to ask anything in this chapter, means in this topic, Gauss law, because this topic is related to area vector, and the main confusion of student is area vector.
Yes, sir.
And if you want to ask anything, then you can please ask me. And today I am not feeling well. I'm suffering from fever today, so I will leave you early.
So
Maybe
we actually started another new lesson in class, sir.
you have
In my class, sir. We
in your
started a
school,
new lesson. Yes, sir. Yes,
which
sir.
natural magnetism or EMI.
So alternating currents.
No problem. Okay, no problem. This chapter is just about to finish. You can see here. This is na. We will study the continuous charge distribution, and after that
Yes.
Gaussian surface. These are small topics that can be finished in the next lecture. Will be the last lecture, and in the coming next lecture we will definitely start, inshallah. Uh, Magnetism we will start. Okay,
Okay,
and
sir. Okay, sir.
we will try to catch up your syllabus of your school also.
Okay, sir.
Okay, there is
Okay, sir.
no problem from my side, and I will complete your syllabus on time.
Okay, sir.
So Ziyad, today I am leaving the class early. Means
Okay,
10
sir.
minutes early I am leaving because I am not feeling well and I have to take one more class after this.
Yeah, okay, sir. No problem.
Okay, so
Thank
please
you, sir.
revise the Gauss law, means
Yes, sir.
all the concepts of the Gauss law. Now,
Yes, sir.
from the next class, we will have just a very simple topic we will have, and after that, I think in the next class I will definitely finish this chapter,